Hello everyone, this is Raghav, SME at the GATE Academy. So in this video we'll see a GATE question. So this was asked in GATE 2012. It's a very good GATE question and most of the student gets confused in this GATE question. If you look at the question, you can see on the board, a solid disk of radius r rolls without slipping on a horizontal floor with angular velocity omega and angular acceleration alpha. The magnitude of the acceleration of point of contact on the disk is. You give some options. So first option is 0, second option is r times alpha, third option is r alpha whole square, r omega whole square under root, fourth option is r omega square. And most of the students, whenever they see this question, so they think acceleration of point of contact is 0. Why? Because velocity of point of contact is 0 in case of pure rolling motion. But it's not the case. First a body accelerates and then it creates velocity. It doesn't mean that velocity of the body is 0 and acceleration of the point should also be 0. Okay. First the body accelerates and then you can see change in velocity. So here, if you look at this question, it's a question of pure rolling motion. Whenever you get any question from pure rolling motion, you try to split the motion. Whenever you try to split the motion, the chances of making an error are very less. So here the question is something like this. He is saying that, so the disk is undergoing pure rolling motion. So the disk is rolling on some surface like this. The disk is rolling on some surface like this. So he is saying that the disk is rolling, so with an angular velocity omega, and it's rolling with an angular acceleration alpha. So at this instant, this is the angular velocity. At the next instant, angular velocity may be different because it's accelerating. So it's a case of pure rolling motion. This is pure rolling. This is pure rolling. This is pure rolling. We can break this pure rolling motion into a combination of pure translation and pure rotation. Why? Because if you look at this disk, when the disk is rolling, you can see the points on the disk rotating as well as you can see the points on the disk translating. So I can say, so pure rolling is a combined motion of both translation and rotation. So if I split this motion, it is pure translation plus pure rotation. Pure rotation. Pure rotation in the sense the disk is rotating about its center. Pure translation in the sense the disk is just sliding on the surface. And that's what happens. If the disk rolls, the new location of the disk will be different. And the points on the disk are rotating as well as they are having a linear displacement also. So linear displacement is shown by pure translation and the rotational effect is shown by pure rotation. Okay. Now see here, so whenever the disk is undergoing pure translation, all the points will have same acceleration as that of tangential acceleration, and that's parallel to the plane on which the disk is rolling. So if you look at acceleration at this point, so it will be r times alpha, and if you look at the acceleration at this point, it's r times alpha. So all the points will have same acceleration. Whenever I say same acceleration, both magnitude and direction will remain the same. And it's pure rotation. Whenever a disk is rotating, so the points on the disk are having two things. Velocity of the points is changing, and second thing is the direction of velocity vector is also changing. Both magnitude and direction of velocity vector are changing here. I can say, so this will experience two accelerations due to rotation. So this is because this is radial acceleration. Radial acceleration is always towards center of rotation. It's r omega square. This is because of change in direction of velocity vector as the disk rotates. And there is one more acceleration, that is tangential acceleration. This acceleration is because of change in magnitude of velocity vector. If alpha is 0, so it will be rotating with constant angular velocity omega, then there won't be this tangential acceleration vector. You take any point, all the points on a rotating body, so will experience two accelerations. So one is tangential acceleration and second one is radial acceleration. Radial acceleration is always towards center of rotation. So here also it will be experiencing so tangential acceleration and radial acceleration, r omega square. You take any point, all the points will experience two accelerations. One is radial acceleration and second one is tangential acceleration. So here he is asking us to find out what is the acceleration of point of contact on the disk. Acceleration of point of contact on the disk. So when the disk is undergoing pure rolling motion. So when the disk is undergoing pure rolling motion, you can break the motion into a combination of pure translation and pure rotation. Here you have a velocity vector, here you have acceleration because of pure translation, and here we are having two acceleration vectors. So one is because of radial acceleration, I mean because of change in direction of velocity vector, and second one is because of change in magnitude of velocity vector. So I need to find the resultant acceleration at point of contact. Here you can see this vector is r alpha in magnitude and the direction is this one. This vector is also of the same magnitude but in opposite direction. So I can cancel these two vectors. And if you look at point of contact, there is only one vector left, that is r omega square. And you can draw a vector diagram like this. So I can say because of pure rotation, so there is r alpha vector in positive x direction. So because of rotation, so there is r alpha vector in the negative x direction, and there is one more vector, so r omega square in this direction. So these two vectors get cancelled, and you can see the resultant. So resultant vector is r omega square. I can say like this: in case of pure rolling motion, acceleration of point of contact will be r omega square. It's a very good question. Thank you.